I think I need to remake it.
Colors. I'm just going to use yellow as my only color.
Okay. There's a meme going around.
Okay, so an ionic compound is when we have a metal and a non-metal. So just to introduce you, this unit is on bonding and all things that go with bonding. So we're going to do some Lewis structures and Bisever model. We're going to also learn about hybrid orbitals and things like that. But to start, we're just going to talk about the three different types of bonds. So an ionic bond is a metal and a non-metal. I'm not going to assume that you know the difference between metals and nonmetals on the periodic table. The nonmetals are to the right of the staircase. The metals are to the left. So when you have one of each, that creates an ionic bond. The ionic bond is caused by the formation of ions by achieving noble gas electron configuration. It's not funny. Can you stop, please? Creates, can you stop, please? Electrostatic attraction. Okay, so some vocab words in there. Noble gas electron configuration and electrostatic attraction. Noble gas electron configuration is back in like 6th or 7th grade or whenever you learned this. You learned that electrons or atoms are happy when they have a full filled energy shell. Okay, so if you ever say an atom has feelings on the AP exam, you will not earn the point. In order to earn the point, in order to earn the point, you need to use the words noble gas electron configuration. These are the noble gases, and all the noble gases have a filled energy level. So the reason why fluorine gains as an electron is not to be happy. They don't have feelings, they're not things, but to achieve the noble gas electron configuration, okay? So formation of ions is due to that, and then when ions interact with each other, they create what's called an electrostatic attraction, which we have talked about before, but we're going to do a little bit more quantitatively now. So lattice energy equals Q1 times Q2 over distance. Electrostatic attraction is the vocab word. The lattice energy is like the quantitative part of it, like how much is it actually. Q1 times Q2 are the charges of the ions that became ions because they were achieving noble gas electron configuration. And then D is the distance between nuclei. So the nucleus is in the center of the atom. The distance from nucleus to nucleus is what goes on the bottom here. So if we increase our charges, +2 minus 2, +1 minus 1, +2 minus 1, it's stronger. Higher charges is stronger. Inverse to the distance, so smaller distance also equals stronger. Okay. Oh yeah, you have to really squeeze in there. So how do you know what the distance is? This is not size as in mass. This has nothing to do with molar mass. I don't look at something and be like, oh, it weighs more, so it must be bigger. That's actually not true. Necessarily. There's a trend on the periodic table. That's really bad. The trend is up and to the right. So helium is the smallest distance-wise, like radius. Francium is the biggest. So upper and righter. We have a whole unit on why that is a trend, but for now you just need to like pick out who's bigger and who's smaller. Okay? This causes really high melting and boiling points. They're very strong. The electrostatic attraction is really strong. You can't melt salt. If I gave you a chunk of sodium chloride and I said, melt it, you could put it over the Bunsen burner all day and it would never melt. Okay? Things that are ionic are too strong to melt, much less boil. When the music starts, talk about this. Use these vocab words at least 3 times each. I'm getting you to practice saying the words. Ready? Go. Oh, thank you. Okay. Covalent bonds mean you have all nonmetals. Nonmetals are to the right of the staircase. Water, carbon dioxide, all of your organics, sugars, those are all covalently bonded. This is from the electrostatic attraction. Those are the words for plus or negative. Between the positive nucleus, it's positive because that's where the protons are, and the negative electron cloud. In a covalent bond, the electrons are shared. Electrons aren't things. They're just energy. So by sharing, I'm not like, I get 2, you get 2. It's like a timeshare. Like the electrons spend more time. Their energy spends more time on one side, but they're not shared equally. Very rarely is it an even Steven situation, like 50% custody. I have to erase this word because I need to draw a graph there. Did you write it down?
Sure.
I also have to erase this because it's going to get in the way of my graph. Okay, so this is a graph. So draw that as your axes. I need a little bit of negative in the y, so that's why I did that. Covalent bonding is very similar to the story of the 3 bears. Do you know what the story of the 3 bears is? Goldilocks and the 3 bears. So I'm not going to assume that you remember, or maybe your parents never read you the story or whatever. But so there's 3 bears: a baby bear, a mama bear, and a papa bear, and they live in a cottage. And then they like go on an excursion, so they leave. And the little girl is like wandering around the woods and finds their cottage and breaks into it. And the whole story is like about ranking, like small, medium, big. So she comes in and she sees 3 chairs, and one chair is, oh no, it's too small. And the daddy chair is, oh no, it's too big. Can you stop? So of course, then she sits on the mama chair. It's just right. And then she notices that the bears left their porch. Porch is like poopy soup. And so she sits down. She's like, oh no, it's too cold. And then she sees the other one. Oh no, it's too hot. And then there's one that's just right. And she eats that one. So for Goldilocks and the 3 bears, it's always a ranking of 3, and the middle one is just right. That is similar to the bond length of a covalent bond. So it has an asymptote on both axes, actually. Can't ever be 0, can't ever be 0. I'm going to do some quantitative and qualitative things, and you need to know both of them, okay? This, the y-axis, is potential energy. Potential energy, we learned already once, is that attraction and repulsion of our magnets. The x-axis, though, is distance between nuclei. A nucleus is in the center of the atom, and then around it is an electron cloud. I did. I put an S instead of an A. Okay. So, no. You guys can't even have a marker. That smells like something. If I have 2 atoms, and if I hold them too close together, they're going to start repelling. And that's because they're surrounded by their electron clouds. So this is being negative on negative if I get them too close. If they're too far apart from each other, then I have no attraction. The electron cloud is not attracted to anything. Okay? So there is a spot that's just right. That's where the bond is going to be. So if my distance here is 0, I'm going to write that in red. So if my distance here, this is 0, let's pretend and call this 10. I'm making these numbers up. It could be 30. The unit is usually picometers. If my distance is 0 between nuclei, that means my atoms are right on top of each other. Asymptotes would never actually hit 0. But they are too close. Oh no, too close. They're repelling each other. The electron clouds are going to be pushing back. They would never get that close. If my distance is way out here, let's call it 10. Oh no, too far. There's no attraction. The attraction is the positive nucleus to the negative electron cloud, plus or negative. But right here, let's call it 5. Right here, where my potential energy is the lowest, that's just right. Just right means that the attraction plus heart negative versus the repulsion, because the electrons are repelling each other, is just the right distance to create a bond. So these questions have 2 parts to them. They have a y part. Y is the bond distance where it is. And they have a quantitative part. What is the bond length?
Why is it when potential energy is like negative, and why is it when it's like at 0?
So at negative, it's just like the lowest possible. So things in nature are gonna like happen where it's like the least resistance, and it just works out to be negative. It's just the lowest possible. I don't know what the units for this is, to be honest. So the quantitative part of it, your answer would be 5. Why? Because that is the distance where the attraction is outweighed by the repulsion. Okay, there's a lot to talk about on this, and you have to know it all. So make sure you talk about all 3 parts of the graph, the quantitative and the qualitative part. And you know the ending of the 3 little bears? They come home and eat her.
Yeah.
The real story, they do.
What's the fake story?
I think they all become friends, don't they?
Just become
My brother bought mice. A metallic bond is when you have all metals. An example could be if I said iron, or maybe I'll say aluminum. So in your brain eyeball, see a piece of aluminum foil, okay? And I said, what type of bond is in that aluminum foil? You might think, well, there are no bonds. It's not bonded to anything. That aluminum foil has a gazillion aluminum atoms that are bonded to each other. So a metallic bond isn't 2 different things making a molecule. It's all of them bonded together to make something, to make a metal, okay? So correct me if I'm wrong. Like I said, I don't know anything about history. But to me, communism is when we have pooled resources, right? So just because person A has a lot of money doesn't mean they get to keep all the money. It's kind of divvied out. In a metallic bond, that is how the electrons are. So these are metal atoms. And the metal atoms, all of them, all share each other's electrons. So the electrons do not any longer belong to a certain atom. They're all just pooled and then shared among all of the atoms. Okay? We call that the electron sea model. Sea as an ocean. And in the electron C model, the electrons are delocalized. Delocalized means that they aren't stuck to a certain atom. They are just pooled and shared by everything. So, because of that, it makes them shiny. It gives them luster. Electrons moving is like energy moving, and it reflects light. It also allows for them to conduct electricity. Electricity is a movement of electrons, and since they are not stuck in place and they're able to move everywhere, that conducts electricity, we can draw them into a wire called ductility or ductile, and we can pound them into sheets. That's called malleability. Because the electrons aren't stuck, if I squish them, everybody just like gets out of the way. They can move out of the way. Okay? Those properties are due to the delocalized nature of electrons in the electron C model of metals. We forgot to fill this in. These have low melting points and boiling points. A lot of times they're gases. Like water is a liquid at room temperature, it's already melted. Carbon dioxide is a gas. Okay? Vocab word delocalized. Delocalized means that they can move freely. The music starts. Talk about communism and metals. What do you got?
They all equally share.
Chapter 8 and 9 worksheet. I just want to do a couple of sample problems to get you started. Your homework is to do 1 through 7. It's just on these types of bonds. Great catch. So likely you're going to have to rank things and explain why. So does the lattice energy of an ionic solid increase or decrease as the charges increase? Our lattice energy Q1 times Q2 is going to increase. Because it's going to be a stronger electrostatic attraction. +2 - 2 is stronger than +1 - 1. If the sizes of the ions increase, so like these big guys down here, not mass, size, like how wide they are. These big guys are going to have a smaller lattice energy because they're further apart, so their distance is greater. In my brain eyeballs, I see like a bus seat, and if you put kindergartners on a bus seat compared to like big seniors, the kindergartners are closer together than the big seniors are, just because they're bigger people. Okay. So now you're going to look at these, and you have to say whether the trend is due to the size, which is radii, charges, or both. Charges trump everything. So look at charges first. If you have a tie for charges, then talk about size. Okay? Do that with your battle buddy, and then your homework is 1 through 7. For that.